yesterday was PSAT day, so a lot of you were gone for that. So if you were not in class yesterday, you need to watch that screencast ASAP. And then after you get done watching that screencast, you're probably going to want to go back and rewatch today's screencast, because it's going to make today's screencast seem, or today's notes seem a lot easier if you know what we're talking about, because we're building off of yesterday. Okay? So yesterday we were talking about logistic functions, okay? And we are focusing more on the left one for now, but we can use the right one also if we have it. But if we're developing our own, we're going to go with the right one, because we don't know how to find k yet in the e function, okay? Or in the e exponent, I should say. Okay? So c is our limit to growth. A, B, C, and k are positive constants, and b is between 0 and 1. Okay? And b, if b is bigger than 1, it's logistical decay. And so that's what we're talking about today. Okay, so we did that yesterday. So today what I would like to do is I would like to graph logistic functions. Okay? Now remember that a logistic function starts out with exponential growth, and then the growth slows and it levels out to the limit to growth. Okay? So how I go about graphing a logistical function is I first start with the horizontal asymptotes. Okay? There are two of them in a logistic function. Okay? The first horizontal asymptote is going to be at y equals 0. That's your bottom horizontal asymptote, and that's provided that there is nothing after the function. If there is something added or subtracted after the function, then that is going to change the entire, it's going to vertically shift the entire function. So then this lower asymptote would vertically shift, and our upper asymptote would also vertically shift. Okay? So, but in this particular case, there is nothing after the function, so we're staying at y equals 0. Our other horizontal asymptote is at y equals the limit to growth, and that in this case is the numerator of a logistical function, and for this problem it is y equals 8. So I would start by graphing those two horizontal asymptotes. There and there. Then this is a logistical growth problem, because this value right here, my value of b, is less than 1. So therefore that makes it a logistical growth. So I would graph myself a logistical growth problem. Starts along the lower asymptote, then rises exponentially, slows, ends along the upper asymptote. Let's see. From that, then, I can graph at least one point. And the one point that I know that I can graph is the y-intercept. How do I go about finding any y-intercept given a function? Plug in 0 for x. So if I input input 0 in for x into this function, I get 0.7 to the 0 power. What is 0.7 to the 0 power? 1. Okay? 1 times 3? 3. 3 plus 1? 4. 8 divided by 4. 2. So I get an output of 2 when I put in 0 into my function for x. Okay? Which means that this point right here is the point 0, comma 2. If I needed to find another point that it went through, well, then what we would do is then we would plug in an x value that's not 0. Like 1 or 2 or 3 or 5 or 92 or 18 or whatever you want to put in there. Okay? And then we can do that same math and get out what the value of that point is. Okay? Questions on graphing a logistical function? With that being said, what I would like you to do now is I would like you to graph me this logistical function. Also give me the horizontal asymptotes and the y-intercept. Numerator. Horizontal asymptotes are where? Y equals 0 and y equals 20. Okay. Growth or decay? Growth or decay? Growth or decay? Actually, growth. Yeah, because it's negative k here. There is a negative sign right there. As long as it's negative k, it makes it a growth. But it's not a B case. It's an E case. This B right here only goes to that one. Yep, there's no B in that problem. Okay, so this is a logistical growth problem. What's up?
So the k in the formula is always supposed to be negative.
Always supposed to be negative. If it's a growth formula, if the k is positive, it's a decay.
Okay.
Y-intercept? Y-intercept in this problem?
Yeah, 0 minus 6 2/3.
I like it, but I don't like it. I like that better than 6 2/3. Okay? We are a fractions kind of a class. Okay? And we are an improper fractions kind of a class, not a mixed up number kind of a class. Okay? Much more exact, much more accurate than rounding this to 6.67 or something along those lines. Okay? Alright? Okay? And much cleaner to leave it as an improper fraction than 6 2/3. Okay? So that's this point right there. Okay? Love it. Okay? So today what I'd like to do is I would like to come up with an exponential, or excuse me, not an exponential, a logistic model for this particular population growth. Okay? So what I would like you to first do is I would like you to input this data into your calculators under lists and spreadsheets. Okay? Gotta title your column, etc. All that fun stuff. Okay? Just to get you started, so we're in lists and spreadsheets here. Remember, we have to title our column. I'm going to go with Y for years and P for population. Maybe. Come on. There we go. There's my P for population. Am I going to go with 1900? What do you want to go with there? 0. I like to go with 0 there, yep. Then this would be 10. And so on and so forth. Okay, so you got all the data inputted into there now. Now what I would like to do is now I would like to create ourselves a scatter plot to go along with that. So most of you do a scatter plot by starting a new page, and then you go into data and statistics and you do this, right? Okay, and that's fine, that's great. You know, you can put your P over here and you can put your Y over here, but the downfall is that I can't put a function over the top of it. Okay, so what I'm going to teach you today is I'm going to teach you another way to do a scatter plot on your calculator. So we're going to start a brand new page, but this page is going to be a graph. Okay? So when I do that graph, now what I'm going to do is I'm going to go into menu, and in my graph entry, I'm going to change it from function, which it is right now, I'm going to change it to a scatter plot. And by clicking on the scatter plot, now it tells me I want to define my x's as whatever I titled my years column to be. In my case, I did Y. Okay? And so that's going to be whatever your column was, your heading for that. It will be bold when you get it right. Okay? And then you go down to the Y, and that's going to be whatever you titled your population column to be. In my case, it was P, maybe. Why is it not typing P in there? There's P, and it's bold, and it's beautiful, and it's gorgeous, and then I hit enter. Uh-oh, I don't see anything. So now I got to adjust my window, okay? Now, let's talk window settings here. X's is years, right? Okay, I'm going to keep it at -10. How far out do I have to go? 120-ish? Okay, I got to go at least to 100, right? Okay, so I'm going to go by 10s. Y's. Negative population, right? Okay, so I don't need negatives there. I'm going to go to -5 though, because I like to see my axes. And 15. I'll go by 1s there. And shabam, there's my scatter plot. Yeah. All right. Now, let's come up with mathematically, we'll come back to that. So now I want to come up with a logistical model that would fit this. So I'm going to say I want it to be f of x equals c over 1 plus ab to the x power. That's what we want it to look like. Yes, sir? Okay. Well, what's c in that function? What is C in my logistical function? It's what? It's the limit to growth, right? Okay. So looking at my data, what would be a logical, realistic limit to growth? For this town or this state or whatever we want to call this. 12.5? 12.5? Rounded to 13, let's say. Okay. It's got to be above 12.3, right? But not pretty much far away, because as you can see here on this one, it's growing, and then it's kind of slowing down a little bit. So I would say 13 in that 12.5 to 13 range. Yep. Okay. All right. So, oops, I missed. So my C, my limit to growth, let's go with 13. Okay. So now my function is f of x equals 13 over 1 plus a b to the x power. Yesterday we developed a couple. What do we do next? What do we do next? What point did we use next yesterday? The y-intercept. Which one's the y-intercept in my data? The top one, right? Okay. So because we said in our graph or in our function that this was 0, that 1900 was 0. So that tells me then that if I use that point, 0, comma 6.3, that now I get f of, oh, I shouldn't even say f of x. What's f of x now? 6.3 is going to equal 13 divided by 1 plus a b to the 0 power. Well, what is b to the 0 power? B to the 0 power. 1. So this is just 6.3 equals 13 over 1 plus a. How do I solve for a? Okay, and then what would you do next after that? Divide by 6.3? Yep, okay. So we could just flip-flop those. Because what you did there is you said you would get 6.3 times 1 plus a equals 13, right? Right? And then you could divide by 6.3 and not have to distribute, right? Okay, so that's what I did all in one step. Okay, and then what? Don't want to solve for a. Subtract 1. So a here is going to equal 13 over 6.3, then minus 1. With me? Now, you may be saying to yourself, well, Linz, why didn't you go through and calculate that out? Well, here's why I didn't go through and I didn't calculate that out. I'm going to start a new page, and that page is going to be a calculator page. And what I'm going to do is I am going to calculate this out now. 13 divided by 6.3, then minus 1. And if I round, now on these calculators, to get the rounded answer, you have to go Control-Enter. If I round, I get that. But what I can do with that on the calculator is I can store that as A. And now the unrounded answer, the exact answer, is stored in as A, and we can use A now, the letter A, anytime that it comes up later on in the problem. Okay? Storing stuff on your calculator is a phenomenal way to go about this. Okay? So that's sitting in my calculator now as that. I'm not even going to write it out on this one because I'm going to use A from now on. Okay? So now we're back to our graph. We have our A. Now what I would do is now I would look ahead and I would say, okay, so I'm back to this. It actually growing, and it's kind of leveling out. So then I would pick a point somewhere down the line that kind of fits where I think it's going to go. And for me, that is this point right there. That to me says that's the one. Because that's kind of where it's in line, and it's the next two are flat, and then it goes up again a little bit more. So I'm thinking that that's the one. Okay? Well, that's the point at 70. So that's this one right there. So that's the one that I'm going to use now to find my B value. Because now I'm going to say 11.8 is equal to 13 divided by 1 plus A times B to the 70th power. Okay. Again, crisscross applesauce. Multiply both sides by 1 plus A times B to the 70th power. Then divide both sides by 11.8. Gets me that. What would I do next to solve for B? In this one, what would I do next? Subtract 1. What would I do next to solve for B? Divide by A. What would I do next to solve for B? 70th root. Okay. So now I would take the 70th root. And that now is what we can put into our calculator. Go back to our graphing calculator, and we can type that in to our function. So there's my 70th root. And now I need to go and I need to get a couple of fractions in there. And we're going to have 13 over 11.8, then minus 1 And here's the cool thing now. I got to divide that by A, right? So I just type in A. It's bold. There's something stored on this calculator as A. And when I get that answer, I get my B value, which I would want to go through and I would want to store that then as B.
So this one was 1.06349. This is 0.967023.
So my function here now is f of x is going to equal 13 over 1 plus 1.06349 times 0.967023 to the x power. Probably. Let's make that look prettier. Okay. On a graph, I can go back to my graph now, and I can test that by going back into graph entry and now getting off of the scatter plot and onto the function. And on that function, I can type in 13 over 1 plus A times B to the x power. And it will automatically pull the A and pull the B into it. And when I hit enter, hopefully it goes on there nice and pretty like. Which it went through our y-intercept that we chose, and it went through our 70th point, which we chose. Okay. Hey, what? The steps of how I put the logistic on there again? Okay. So I went into my function, right? Now, if you're still on scatterplot, you got to go into menu first and then go back into number 1, the function. Okay, because you were probably still on scatterplot. And then I created, because it's going to be a fraction, I created a fraction. Control divide. Numerator is 13. Denominator is 1 plus A times B raised to the x power. Hit enter. There it is.